All right, so this first page is a keep on practicing. And normally I would show all the answer, but I wanted to talk a little bit about these. So I've done some of the work ahead of time. I know that this is a 4th degree, which means that there'll be 3 terms. Okay, I factored out an x squared. So then this made the second term the difference of 2 perfect squares. So this has 3 zeros. So x squared, set it equal to 0, that's 0. But because it was squared, that's going to be a double. Then here's -1, +1. And the y-intercept is a little bit hidden because there's not a constant at all. So that's going to be 0. So I could draw this pretty simply. I know I'm going to go through 0. And then -1 and +1. And it's going to have 3 turns. So a 3 turn is 1, 2, 3 turns. So it's either going to be facing like a M, or it could be facing like a W. And since this is positive, then it's going to be facing, this is when it's positive. When the leading coefficient is positive, and this is negative. So I know that it's going to go through -1, this, and that. So it's going to look like this right here. So it pierces through at -1. Earlier, I talked about it bouncing. So the double doesn't actually pierce. It just touches it, but it doesn't go through. And then at +1, it goes through. So that's just a really quick graph. Then this next one, let me see if I can get this to move over a little bit. There we go. This next one, I've done some of the work already. So this was a double. So that means it's gonna not pierce through at 4. This is the difference of 2 perfect squares. So I've got -5 and +5. And the y-intercept is 800. So that's gonna be kind of a crazy graph. So I'm gonna count 1, 2, 3, 4, 5, 6, 7, 800. And then I'm gonna count this as 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is +5, this is -5. Okay, now this one started off with a negative. So this one is gonna face more like the letter M than the letter W. So it's gonna double at 4. Okay, so 1, 2, 3, 4, this one. At 4 is a double. Okay, so this is gonna be a little bit different shape. So it's gonna come at -5, it's going to pierce through at -5. It's going to come over here and hit 800. Then it's going to bounce on that 4 and then pierce through at the +5. So it's a little distorted. All right. So then on this side, we start a brand new topic. We're going to start long division. And actually someone sent me a text message asking if I could explain this. So long division, remember like back in elementary school when you learned long division? You would look, will 26 go into 3? No, so then you would go back 1 digit. Will 26 go into 39? Yes, it'll go in 1 time. So you would put a 1 above that digit. You would do 1 times 26, which is 26. And then you would subtract. Okay, so that's great. So that's 13. And then remember, you would bring down the next term. Okay, then you would look again. Would 26 go into 1? Nope. Will 26 go into 13? Nope. Will 26 go into 138? Okay, so here is a trick. So 138 divided by 26 is going to be a decimal, but I know at least it goes in 5 whole times. So now I can do 26 times 5. And that's 130. So 130, then you subtract, and that leaves 8, and then you bring down that other digit, and you ask yourself, will 26 go into 8 or 83? Well, it's gonna go into 83. And it goes into 83, 3.19, so I know that that's 3 times. So 3 times 26 is 78. Okay, then you subtract again. Okay, so that's going to be 5. So then when you were probably in 3rd grade or 4th grade, they might have done, a lowercase r, and you would just write remainder 5. But the proper way to do that is 153. Then you take what won't go in perfectly, and that becomes a fraction, and 5 over 26. So the 5 is your numerator, the 26 is your denominator. Okay, so let's apply that same thing to a polynomial. Okay, so I'm going to write this out. So I'm going to take 3x plus 4, and I'm going to try to put it into 6x to the 3rd plus 17x squared plus 27x plus 20. Okay, so just like we did up here where we would see if it goes into 3, and then it didn't, so we had to go 39. Okay, you're going to ask yourself, will it go into 6x to the 3rd? Well, no, because I've got 2 things, so I'm going to have to come back here and try to figure out these 2 things. So when you're looking at this, you only want to look at the front terms. So you're just asking yourself, 6x to the 3rd divide by 3x, or you could ask yourself, what would I have to multiply 3x by to turn it into 6x to the 3rd? That's probably a better question. So 3 times something that equals 6, well, that's 2, and x times something that equals x to the 3rd, well, that would be squared. This pen is running out, so that's not a good choice. So that's going to be 2x squared is what I have to multiply by. So now multiply 2x squared times 3x plus 4. So that's going to be 6x to the 3rd, and then 2 times 4 is 8, and that's x squared. So then you're going to, there's a fun little poem that actually one of my college professors would always say. So you're going to draw the line and then change both of those signs. So that was because you're subtracting. But subtracting just means that this is going to not be a 6x anymore. It's going to be a negative 6x. And that's not going to be an 8x squared anymore. It's going to be a negative 8x. So then what should happen is your leading terms should cancel. That's great. Now I have 17 minus 8 is 9. So I'm going to do 9x squared. And then just like we did here where you brought down a term and you bring down a term, I'm going to bring down this next term. So I'm going to bring down 27x. Okay, then you're just going to ask yourself, you're only having to look at these front terms. So look at 3x, and you're just asking yourself, what would I have to multiply 3x by to turn it into 9x squared? So 3 times 3, so that's going to be plus a 3. And then what would you have to multiply x by to build it up to x to the 2nd? Well, there'd be 1 more x. And then you're going to take this 3x and multiply it. And that's going to give me, so 3 times 3 is 9. X times x is x squared. 3 times 4 is 12. Okay, then, here's that my college professor would always say, draw the line, change the sign. He thought he was cute. So we're going to draw the line. That's not going to be a 9x anymore. It's going to be a negative 9x. That's not going to be a 12x anymore. It's going to be a negative 12x. So then what should happen every single time are these front terms should cancel. Okay, then what am I left with? I'm left with 27 minus 12. Okay, so that's going to be 15. Okay, then just like regular, 4th grade division, you're going to go grab the next term and bring it all the way down. Now you're just asking yourself, what would I have to multiply 3x by to turn it into 15x? Okay, well, 3 times 5. So I'm going to write a plus 5 up here. And I already have the x, so I don't have to build the x up anymore. So that's going to be 15x plus 20. Well, that's great. So then you're going to draw the line and change both of these signs, and they both cancel. So my answer is 2x squared plus 3x plus 5.